I want to start by talking about the characteristics of the data. Have always a center. A center is a representative or average that indicates where the middle of the data set is located. So any set of data, we have a center. We also have a variation that is a measure of the amount that the data values change among themselves. We have the distribution, the nature or shape of the distribution of the data, such as a bell shape, a uniform distribution, or an skewed distribution. The outliers are sample values that lie very far away from the majority of the other sample values. The time, that is changing characteristics of the data over time. Now, when we collect data, we need to organize the data. So, especially when we have a large data set, it's very helpful to organize and summarize the data by constructing tables that list the different possible data values along with the corresponding frequency. We represent basically the frequency is basically the number of times that this in the data set. Some important concepts related to the data are frequency distribution into data using classes and frequencies. The class, that is a qualitative or quantitative category. Class limits, that are the smallest numbers that can belong to the different classes. The upper class limits, that are the largest numbers that can belong to the different classes. The class boundaries, that are the numbers used to separate the classes, but without the gap that is created by class limits. The class midpoint, that is the midpoint of the classes. And the class width, that is the difference between two consecutive lower class limits or two consecutive lower class boundaries. Example, suppose that we have the data set given. As you can see, this data set is not in order. Usually, well, when you have a data set is not in order. So we have this set of data that contains 5 columns and 1, 2, 3, 4, 5, 6, 7, 8 rows. So it's 40 entries basically. And then we want to construct the frequency distribution for this data set. The first is to decide the number of classes you want. The number of classes should be a number between 5 and 20. How many classes will you select? Well, it depends specifically on the number of data entries. So imagine if I have 40 data entries, it doesn't make sense to select 20 classes here. So I have a relatively small number of data entries. 40 are not too many data entries, not too many data values. So I decide to construct my frequency distribution with only 5 classes. So the next that I have to do is to calculate the class width. How do you calculate the class width? To calculate the class width, you will round the result to get a convenient number. Usually you round up. The priority should be to use values that are easy to understand. The class width will be equal to the highest value of your data set. In this data set, the highest value is 191, and the lowest value of your data set, that in this data set, the lowest value is 0. So to calculate the class width, I subtract the highest value minus the lowest value. And then we divide this by the number of classes that I have defined in my previous step. When I do the calculation, I get that the class width is 98.2. So I decide to round this up to 100. Right? 100 is a convenient number. You could also round it to 99, but it's going to be a little bit more difficult, in terms of, the limits of the different classes. So I just round it to 100. It should not make a big difference. Then later you should select what is called the starting point. So you should choose a number for the lower limit of the first class. You can choose either the lowest data value or a convenient value that is a little bit smaller than the lowest data value. In this case, the lowest data value that I have is 0. There is no number little smaller than 0 that I can use to just be more convenient. So I define as a starting point the 0, right? So as 0 is my lowest number, that would be the starting point of my data set in this case. Or my starting point to define my classes in this case. So once I have my starting point, I would be adding the class width to the starting point. And like that, I will determine the second lower class limit. And I will repeat this until I obtain, the class limit of each class. Remember that I have 5 classes in this example. So I am adding, in this case, a starting point 0 plus my class limit of 100, which is equal to 100, and 100 will be the lower class limit of the second class. Later, I will be adding 100 plus 100, and 200 will be the lower class limit of the third class. Later, I will be adding 100 to 200. I get 300, the lower class limit of the next class, that is the fourth class. And then I am adding 300 plus 400. I will find the lower class limit of the next class. And then, of course, the next class will go then from 400 to 499. Now, when you have lower class limits, you will list the lower class limits vertically. By my lowest class limit of the first class is 0, the lowest class limit of the second class is 100, the lowest class limit of the third class is 200, the lower class limit of the fourth class is 300, the lower class limit of the fifth class is 400. If you go back to what I said is class width, we said that class width is different, between highest, lowest value divided by the number of classes, right? But also, we said, right, that in this case, in the definition that I gave you of class width at the beginning, we said that is the difference between 2 consecutive lower class limits or 2 consecutive lower class boundaries. So you find the difference between 100 and 0 is 100, between 200 and 100 is 100, between 200 and 200 is 100, between 400 and 300 is 100. And the same thing, you subtract the upper class limits. So 499 minus 399 is equal to 100, 399 minus 299 is equal to 100, and so on. So now here I have my 5 classes. The first class will go from 0 to 99. The second class will go from 100 to 199. the third graph from 200 to 299, the fourth graph from 200 to 299, and the fifth graph from 400 to 499. So these are my lower class limits, and these are my upper class limits. After that, you will just put in a column your class limits, and you will make a tally, to count, in this case, of course, how many of the values of your data set are lying in each class limit. So I can see that, for example, between 0 and 99, I have 11 values. So the frequency for this class is 11. So that means that 11 numbers in my data set are between 0 and 99. 12 numbers in my data set are from 100 to 199. 14 numbers in my data set are from 200 to 299. One number is between 300 and 399, and two numbers are from 400 to 499. In total, the frequency needs to be equal to the total number of data values. The sum of the total frequency needs to be equal to the total number of data values. So I had 40 data. The total frequency here is also 40. So this frequency, this table that you see, that have the class limits and the frequency, is what is called a frequency distribution. This is what is called a frequency distribution. Of this step 6 is what we call frequency distribution. So you know that you have that there are 11 values like 0, 99, 12 values between 100 and 199, and like that. So you have classes, you have your data organized by classes, and you have then the number of times that each of these classes occur. Now, in the table, and just calculate the relative frequency and get a relative frequency distribution. The relative frequency distribution includes the same class limits as the frequency distribution, but you're going to use relative frequencies instead of the actual frequencies. To calculate the relative frequency, you will basically find the quotient of the class frequency over the sum of all the frequencies and multiply that times 100. So for example, if I want to find the relative frequency of the first class that go from 0 to 99, what I have to do is to divide the frequency of this class, which is 11, by the sum of all the frequencies, which is 40. And when I divide 11 by 40 and multiply times 100, I get that the relative frequency of this class is 28%. By that, you can find the relative frequency of the second class. So you divide 12 by 40, you get that is 30%. And like that, you can calculate the relative frequency for each class. At the end, the sum of the relative frequencies must be equal to 100. You can also have a cumulative frequency, and the cumulative frequency for a class is the sum of the frequency for that class and all the previous classes. So when you have a cumulative frequency table, you have that your class limits are values less than 100, less than 200, less than 300, less than 400, less than 500. Less than 100, I have 11 values that are those values in my class that go from 0 to 99. Now, less than 200, it includes the values of the first class that go from 0 to 99 and the second class that go from 100 to 199. So we have 11 plus 12, which is going to be 23. So this 23 that you see as cumulative frequency here, is the number of values that are less than 200, so that the number of values of data set or data values that are included in the first two classes. If you find the cumulative frequency of the values that are less than 300, then now you should include all the values of the first three classes. So you have from 0 to 99, 100 to 199, to 200 to 299. Now, at the beginning, we mentioned the class points. And we said that we write the categories to close the gap between, the different classes. Because if you check, for example, upper class limit of the first class is 99 and the lower class limit of the second class is 100. So there is a gap of 1 unit between the upper class limit of the first class with the lower class limit of the second class. There is also 1 unit of difference between the upper class limit of the second class with the third class, with the lower class limit of the third class. So always we have a gap for this frequency distribution of 1 unit. So if you want to close the gap using the class boundaries, what you have to do is basically to find the size of the gap first, and you know that the size of the gap is the upper class limit of one class minus the lower class limit of the next class. So upper class limit of class 2 minus, lower class limit of class 2 minus the upper class limit of the class 1. Or you can say upper class limit of this class, for example, minus the lower class limit of the next class. So basically the same. Is 190 minus 200 or vice versa. So you get the size of the gap, and the size of the gap is 1. So it's evident that it's 1 because you subtract, as I said, 100 minus 99, 200 minus 199, and like that you can just get the size of the gap. Now, you will add the half of the amount, the half of the size of the gap, to each upper class limit to find the upper class boundaries, and you will subtract the half of the amount, the size of the gap, from each lower class limit to find the lower class boundaries. That means that now your, for example, upper class boundaries are going to be 99.5, 199.5, 299.5, 399.5, 499.5, and the lower class boundaries for each class are going to be 0 minus 0.5, minus 0.5, 99.5, 199.5, 299.5, and 399.5. Because you subtract 0.5 from each lower class limit, and you add 0.5 to each upper class limit. Also, we can find the class midpoints. And to find the class midpoints, we can find this by adding the lower class limit to the upper class limit divided by 2. So, for example, the first class midpoint, the class midpoint of the first class is 0 plus 99 divided by 2, so it will be 49.5. Like this, in this other case, between 100 and 199 it will be 149.5, between 200 and 299 it will be 249.5, and like that. Now, once you have your data organized, either as a frequency distribution like this one, or as a relative frequency distribution, right, or as a cumulative frequency distribution, well, then you can just construct a graph to present in another form, you know, your